Hello, welcome back. We're going to continue our discussion on solving differential equations using separation of variables. So let's take a look at example number 6. So here we are given the initial condition, y of 4 equals -2. We want to solve the following differential equation. All right, this is where the fun begins. Notice this time we have these exponential functions. So the first thing I'm going to do is I'm going to factor out an e to the x. In other words, I'm going to factor out an x. All right, so when I factor it out, I'm going to get this dy dx, and we get e to the x times 3 plus y. Once I do this, now I can bring my 3 plus y to the left side by dividing it, and remember, we're going to multiply both sides by dx. And that's going to give us 1 over 3 plus y equal to, whoops, oh no, terrible error. I forgot my dy there. So let's see, we got that. There's our dy equals this e to the x dx. And now I'm ready to actually just integrate this. So the antiderivative of 3 plus y, yep, that's our u substitution here. So we're going to let u equal 3 plus y. Our du is just dy. That's kind of nice. So when we rewrite this, we're going to be left with 1 over u du, which is the natural log of u, which we said was 3 plus y. On the right side, we're just going to integrate e to the x. That's just e to the x plus your constant. Exponentiate both sides, and we're going to get this absolute value of 3 plus y equals, this is fun, e to the x plus c1. And don't forget your little algebra trick here. We're going to write this as e to the x times c e to the c1 right there. Isn't that fun? Now, we're next going to say we're going to convert that e to the c1, so we're going to let e to the c1 equal c2. So my new equation, if I can go ahead and get rid of the absolute value, we're going to put the c2 in front, and we get c2 e to the x. So there's our general equation. And the last thing oh no, we got plus or minus. Remember where the plus or minus came from? When we took that absolute value, we get plus or minus. Now, my initial condition tells me that y is, that y is going to be negative here. And that's the one I want to pick. So I can go ahead and write that if I wanted to. 3 plus y equals negative c2 e to the x. Plug in your initial condition. We're going to find c2 by plugging the point 4 and -2. Just plug this in. If I plug -2 in for y, that's just going to give us 1 equals negative c2 e to the fourth. Oh boy. So let's see here. So c2 would equal -1 over e to the fourth. And then I can write out my final equation. 3 plus y equals negative of a negative 1 over e to the fourth, whoop, times e to the x. That's just weird looking, honestly. So we're just going to leave that alone. If you want to, yeah, you can make those two negatives positive. All right, let's take a look at number 7. Same type problem. So I want to, well, if you need to, go and pause it. Try number 7 here real quick. We want to solve the particular solution. Remember, anytime we say the word particular solution, they're saying use separation of variables. So we want to separate the variables here. And let's go and do that. We're going to bring a y over. That's just 1 over y dy. Again, leave the 4 with the x cubed and just bring over the dx. And that's going to equal 4x cubed dx. There we go, 4x cubed. When we integrate, we get the natural log of y, and that's going to become just x to the fourth. You can verify that. Plus c1, and Michael Jackson said, just e it. That's what we're going to do there. So we get the absolute value of y, and this becomes e to the x to the fourth times e to the c1. That's our little algebra hack. Remember, if we're multiplying, if we have the same, but if we are adding exponents, we can write them as the product of two separate bases, like so. And that's what we're doing. We normally just go the other way, that's all. So when we simplify this, we are now going to say, let e to the c1 equals c2, e to the c2. And I'm going to get rid of my absolute value here. That becomes plus or minus c2 e x to the fourth. And look, notice this should look familiar. Remember, that's our PERT. That's p e to the rt. Ready? P e to the rt. Right there. That's pretty. I mean, pretty ugly if you ask me, but that's cool. So we're now going to find C2 by using the initial condition 0, 8. So be careful. Y is positive. So what that's telling me to do, I'm going to pick the positive C2 e x to the fourth. Plug in 8. I get 8 equals C2. E to the 0 is just 1, so therefore C2 is 8. And my equation, we get 8ex to the fourth. And there's our final answer here. All right, let's go take a look at an AP type of question here. So here's an AP question. We want to consider the differentiable function, let y of equal f of x be a particular solution to this, and they want me to graph a sketch field. So I know you guys can do that real quick. So I'll let you guys do it. Sketch fields are pretty easy, but I want to get down here to where it says write the equation of the tangent to the graph. This is our tangent line problem. So we want to write the tangent when x equals -1. And that's not too hard to do because up here, they tell us at -1 the value of the function is 2. So we have a point, and the point is just -1, 2. And to get the slope, we're just going to use our derivative. Remember, our derivative is right up here. There's our derivative. It's the very top right there. I'm just going to plug my point into there. I get negative of a -1 times 2 squared over 2. And that just becomes 4 over 2, which is 2. So my tangent line will be y minus 2 equal to 2, and then x plus 1. And there's our tangent line. And now they say solve for f of 1.2. So they're now just saying, we're going to let x equal 1.2, and I'm going to plug that in. Y minus 2 equals 2, 1.2 plus 1. That's interesting. And I'm just going to plug it in. Y minus 2 equals, and this becomes 2 times 2.2, and that's 4.4 plus 2, which is 6.4. And there's our approximate value right there. All right, very easy to do, very fun to do. Look how easy that is. All right, so for the next one now it says to, remember, Part B is only an approximation. It is not the exact value. For Part C, now they want us to find the exact value. So now they're saying, this is just my tangent line is just an approximation. It could be this. But now they're saying, well, give me what it really is. Tell me what it really is. That's what, when we solve a differential, that's what we're looking for. So we're going to set this up. We got dy dx equals negative xy squared over 2. And I want to separate my variables. I'm only going to bring over the y squared. I'm going to leave everything else I'm going to leave all the rest here over on the right side. Only bring over the y component, and that gives me 1 over y squared dy equals negative x over 2, and I'm going to multiply by the dx. When we integrate, be very careful. This is really y to the -2 dy. And if you want to, this is just negative x over 2, dx, leave that there. Now, you can verify this. This is just going to become -1 over y, one of those, equals negative x squared over 4 plus c1. Now, this isn't my natural log problem right up here. This is not our natural log because we got 1 over y, which is not natural log, so I don't have to exponentiate. So this is the time, a special time, when I can go ahead and find C1 right now. Makes it a little bit easier for us. I can find C1 right away. So to find C1, I'm going to use the condition that they gave me, -1, 2. And notice, if I plug it in, if I plug 2 in, I get negative a half equals, plug in the -1 squared, I get -1/4 plus C1, add 1/4. So C1 is just going to be -1/2. Plus a fourth, which is going to become, what's that, -1/4. So there's C1. Rewriting your equation, -1 over y becomes negative x squared over 4 minus 1/4. And I'm going to get rid of the negatives here, just multiply through. Since I already have a common denominator, I'm going to go ahead and rewrite this. This just becomes x squared plus 1 over 4, and I can just flip it, flip both sides. You have to have a common denominator in order to do this, though. And that's going to become 4 over x squared plus 1. And there's your function. All right, hope you guys enjoyed the video. I will see you all later. Bye-bye.